So what have you guys been up to at home?
Nothing. I mean, just trying to brush up for our online exams and all that, and other skill development stuff, online courses and stuff. That's from my end. I'm not sure about the others.
I mean, it must be weird not being in college. I mean, I can't imagine what you guys are going through.
Yeah, missing out a lot because the first years were there for just a few months, and we
Mm.
spent just the first semester. So it's a bit difficult for us to explain it to them how amazing it is, and it's difficult for even our seniors to explain it to us that how amazing it is in college for like years.
Yeah, for sure. I mean, the entire point of college, I'd say, is the experience of actually being there and interacting with your peers and mentors and teachers, and the
Yeah,
labs and the activities and Saturday nights, with all of that.
yeah.
But yeah, I mean, like it's weird times overall for everybody in the world. So um, we have to persevere, I suppose, make the best of what we can.
Agreed. Uh, yeah, I guess we can start now. Arun, go ahead.
Okay, so first of all, good evening, Vijay sir, and to everyone present here. Thank you so much for taking time to attend the second interactive session with Fractal Works through ISA. Mr. Vijay is an alumni of our college Mechatronics Department batch 2014 and is the founder and CEO of Fractal Works, which is a startup of our college which works on the trending field of 3D printing. So thank you so much for joining again, and sir, it's an honor to have you with us today. You may begin from your part, sir. Yeah.
Yeah, thanks for having me. I'll just share my screen. Sharing my screen. Okay, you can see the presentation one, right?
Yeah, it's visible.
All right. Thanks so much for having me on again. It's always a pleasure interacting with students. I'm gonna try and sort of speed up the presentation part so that we can have more lively discussion at the end. So the objective of my presentation is basically to give you a brief overview of where I came from and my journey in Manipal and how I sort of ended up starting up a company. And with sort of any beginning, my beginning also started with childhood. So I had a pretty fairly normal childhood, but one thing set it apart. Nobody would buy me any toys, even for birthdays or Christmas, and they had good reason to, because most of them were end up like this. I was a curious kid who would always rip stuff apart, and they wouldn't necessarily come back together. My father, being a very smart man, again, yesterday was Father's Day, so I wished him. He had came up with a pretty ingenious solution that, and told me I could have whatever I wanted, but they were the caveat being I had to build them myself, and I didn't mind at all. And while building things, I felt like Dexter, and I emulated him, wanted to emulate him, wanted to grow up and be like him. I wanted to be like Dexter. I wanted to wear a white lab coat. I wanted to build robots. I wanted to build things that save the world. Credit to my father. I think great way to trick your kids into taking up engineering. But so with that sort of goal in mind to be like Dexter, there's only one career choice in India that you can sort of goes down this path. So I decided to take up engineering. And curious story. Again, all of you have been there at counseling when you have to select your branch, right? Everybody asks like, what branch do you want to be in? I was very clear from the very start. I mean, what kind of engineer is Dexter? He's not. He does electronics. He does mechanical stuff. He does code. What is he? He does chemistry. So I figured like the only course that made sense, only branch that made sense is mechatronics, because that had at least a little bit of all. So I assumed Dexter to be a mechatronics engineer and joined Manipal University as a mechatronics engineer. Now the first thing I realized when I got to college is that engineers do not wear lab coats. They wear these. I mean, sad for even most of you that you don't have this experience. Sad, is it fortunate or sad? I'm not sure, but yeah, when you go into the workshops, you wear something that look like auto driver's uniform. But again, that was at least like something. Uh, ठीक fine. I didn't get to wear a lab coat, but at least I got to build a lot of robots. I was in the founding team of Robo Manipal, and we made a lot of robots. I got into competitive robotics where I would build robots and take them all across the country. I won competitions in IIT Bombay, NITK, NIT, like all over. And then Robo Manipal also did really well, going to the nationals and appearing on national television. So this is where really I got started. I sort of built my bearings with robotics, and I really fell in love with robotics. Um, I'm not sure if students uh, still, sorry, parents still tell their children this, but my parents told me that hey, you pay attention in your 11th and 12th, and then college is chill. You don't have to worry about marks anymore. So I took that seriously. My I was about an average 7 pointer. I've spent most of my this was that last video was my room in ninth block actually. So my entire room was like a semi robotics workshop where I would build all sorts of stuff, and my academics were okay, so, but I was having a lot of fun in college. One of the robots which I was making is, again, I've always learned things while doing, and I wanted to learn the software called LabVIEW. I wanted to learn signal processing, and I wanted to mix that with robotics. And my specialty was sort of human machine interfaces, because I used to take part in a lot of competitive robotics competitions where it's almost like a game where you are controlling a robot to do several tasks, and the better you get at control, the better you would win. And that was sort of my secret sauce at winning a lot of robotics competitions all across the country. So I was really curious about signal processing. Could I use my brain waves to control a robot? So I was doing a lot of research and sort of ended up with something that actually works. And this is again published a paper on this, well cited. It got a lot of attention, got the college's attention, and we basically ended up winning Provenance, which is Manipal's business plan competition. Uh, and uh, that was really weird. Up till that time, my goal was to pursue higher studies, get into MIT, the MIT, and pursue robotics in my master's, become a robotics researcher. That's what I wanted. But ultimately, here I was in the third year of college. I had the opportunity to start up a company. Basically, the college intended us to create a wheelchair for the paraplegic, for the people who paralyzed, and they so that they can control the wheelchair with their mind. So I was like, okay, fine. I'm in the third year of college. I have nothing to lose. College is giving me office space and money. Uh, at the very least, this will look good on my CV. So I'm like, ठीक है, चलो करते हैं this entrepreneurship thing. So that's how we started. And again, we had to convert something that looks like this, which is literally a tiffin box on wheels, into something that would actually be a product. And I remember going all across Manipal, Mangalore, Hyderabad, Mumbai. Again, no one to really help somebody who's a student with no money, and only willpower was keeping us going. So we were determined to figure out a solution to this. We wanted to build something that looks like the final product. And that's where we learned about two important concepts. So one is 3D printing, this way of converting a digital file into a reality, and open source hardware, where a lot of the source files have been made available for building something for free online. And we were able to sort of leverage open source hardware and the lot of the designs for 3D printers that were available, and built our own 3D printer with the intention to create our robot, our wheelchair for the paraplegic. But like any other, I mean, like we were not very professional back then. We were like, ooh, shiny, and would sort of get very easily distracted. So 3D printing obviously was an amazing technology. It completely sort of took the limelight for us. Ultimately, the printer did not work really well. I mean, we ended up. I used to sleep next to the printer, listening for sounds, making sure that something was if something is up. I would sort of like wake up, fix it, and go back to sleep. I would basically sleep off in the innovation center, and that was basically how it went. Uh, and what was happening was we would 3D print upgrades on the 3D printer and make it better and better and continuously make it better, and eventually the 3D printer ended up like this, something that worked really well. um, and we were doing projects for students all across the university. So for the final year projects or architecture projects, people used to come to us and get stuff 3D printed, and that's where we really felt that, hey, we are onto something now. We have a company registered, we have some amount of money, we have a product also now that people want to use. Let's start up a company. And that's how sort of we ended up starting up Fractal Works, manufacturing 3D printing to begin with. And that's how we started our entrepreneurship journey. And I was still in the third year, my co-founder was in the second year. We still didn't have any money to start, so we recruited our classmates, recruited our friends. We'd meet up after class and build 3D printers. We sold quite a few 3D printers in our college itself, and that's the reason by the time I reached fourth year, I opted out of sitting for campus placements, and decided to sort of pursue Fractal Works full time. I mean, I might make it sound like it was an easy decision, but for sure, I mean, it was something that took a lot of deliberation from my end, from my parents, because ultimately, I mean, that is not the norm. Even back in 2012, 2013, startups were not like a mainstream thing. That I'd say the word was also not mainstream. But anyway, I think now there's no regrets. The company is doing decently. We've built a range of 3D printers. It's been what, almost 8 years since I graduated. almost 8-9 years since Fractal was born, and we've built all sorts of 3D printers with everybody in mind. Our 3D printers are used by architects, fashion designers, shoe designers. Doctors use 3D printing for surgery planning, where they will convert X-ray, CT scan data into 3D printable data and practice the surgery on a 3D printer. Actually, just today we got one case, and we have an entire range of 3D printers, everything from beginner level for students and college students to industrial printers, which are being used by the likes of Tata Motors, TVS Motors, to build jigs and fixtures, prototyping on their bikes and cars. And again, IIT Bombay, IISc Bangalore, sort of you name it, our printers are across the country today. Manipal themselves, I mean, like if you were in Manipal, next time do check out our printers. We're there in the mechatronics department, in the innovation center, and the and Walter actually is there in the MIT workshops. So do check them out. So 3D printing really enabled me even to start a company, and really, like, 3D printing as a technology, it sort of levels the playing field when it comes on manufacturing. Typically, manufacturing is hard, but 3D printing sort of made it easy. We were able to um, make things at a very high quality and do things. But that's not it. I really wanted, I mean, entrepreneurship and all was good, but ultimately, I am an engineer in heart. I'm a maker at heart, and business and all is like obviously is a big part of what I do. But I'm somebody who always had to be engaged with, not only building 3D printers, but also figuring out how I use 3D printers, and also sort of going back to my roots in Manipal, um, in Manipal, to teach students about robotics. So I ended up publishing a book on 3D printing, sorry, on robotics and electronics, which is doing really well. But that wasn't enough. I wanted to do more and apply myself to solve like real world problems. Um, so smartphones are really amazing. They enabled us to do a lot of interesting things, from travel to eating. But the absence of physical buttons on a smartphone left a whole group of physically visually impaired blind people that struggle to use smartphones. So again, I was at a conference where I was seeing people who are blind, who are struggling to sort of like use simple things on the smartphone. So I thought there has to be a better way to do this. So I created Tipo, a interface for the visually impaired, and this would use their existing sort of Braille methodology for typing. So there's no learning curve. If somebody who's blind knows Braille, they can start using the device. And I released, sort of going back to how I started as a company, we released the designs open source, so anybody in the world can recreate this. And that's how, again, people all across the world and in India have been building this. There's another company that is formed specifically for this, called Hebel, in the Netherlands, who's again from one of another graduate alumni of Manipal, and a teammate of mine who was working on this project started a company specifically for this. And again, a lot of people sort of remix this into a finished smartphone. So that's sort of the power of open source hardware and sharing, which sort of like is something that I always looked at doing, how I can use engineering to make solve problems. Um, so I'm also a passionate environmentalist. I still cycle today. I've been cycling since school. I've probably done about 5,000 kilometers in the last couple of years. Again, even during the last pandemic, sort of the only way I was able to sort of get to office was on a cycle. Nobody really stops somebody on a cycle. Police officers don't really care. But again, I wanted to do more. I wanted to contribute more, be a part of a bigger solution. Climate change, in my opinion, is one of the biggest threats facing mankind, and again, and I wanted to be a part of a bigger solution. So that's where I met this man. So he's Sir Robert Swan. He's the first one to walk to both poles, north and south. And I fell in love with his undying commitment to fix the planet. and he selected me to go on a journey to Antarctica, to the South Pole, with amazing people from all around the world, ranging from climate scientists to musicians to policymakers. And I wanted to use Antarctica as a platform to sort of showcase 3D printing and engineering and inspire other engineers like myself to take up arms against climate change. And I use the tools at my disposal, 3D printing and open source hardware, to make access to renewable energy more easy for all engineers. And I then set up the world's first 3D printed wind turbine in Antarctica. So that's me. That's Fractal Works. That is a penguin there. You can see that guy. Penguins are really interesting creatures. They have quick, interesting fact that penguins do not have any predators on land, which makes them incredibly docile, and they will come and very curiously peck at you and try to see who you are. So yeah, penguins are pretty interesting. We had to sort of keep all our equipment because penguins keep opening up our bags and taking stuff out. Um, so yeah, that's the story of the wind turbine in Antarctica. So I was not definitely not alone. I got support from everywhere to get me to Antarctica for the fundraiser, as well as there was a multinational team of people helping sort of set it up, and the wind turbine sort of became a symbol of teamwork, how we have to come together and work together to solve problems. And even me at Fractal, it wouldn't be possible without my team. Um, and I'd say again, the message I want really for you to take back from this is, as sort of my fellow engineers, again, we need to work together to solve problems. And the future definitely needs fixing. There's so many problems at hand. Again, currently the economy is tanking. The pandemics are on a rise. Climate change is a real threat. They're just again from everything from renewable energy, access to renewable energy, to access to electricity in remote parts of the country and the world. There's so many things that need fixing. But again, I predict a bright future for all of us, because I do believe that the best way to predict the future is to create it. And what what better profession who has the ability to create things than engineers. Ultimately, I joined engineering because I wanted to wear a lab coat like Dexter, but ultimately realized like you don't wear lab coats in engineering. So the R&D department in Fractal Works wears lab coats. And it doesn't, obviously, story doesn't stop there. Last pandemic, we were engaged with 3D printing PPEs and face shields to sort of give frontline workers much before anybody else could start manufacturing. This second wave, we started manufacturing oxygen concentrators, and currently we're looking at certifying it, and then probably in the next coming months we'll start manufacturing it and selling it. Um, so yeah, that I come down to the conclusion of my talk. Again, engineering is, in my opinion, an incredibly beautiful profession. There's a quote that I really like, called, "Scientists study the world as it is, but engineers create the world that has never been." And if you see the progress that mankind has made in the last 100, 150 years, it's only because of engineers that we have had such amazing progress across engineers who are applying themselves across fields of computer science, of biotechnology, of civil engineering, of technology, of consumer electronics. And I was lucky enough to meet Abdul Kalam in 2014, showing him some of the stuff that I was doing with Braille. And he told me, almost like made me promise that whatever you make sure, whatever you make an engineer, make sure people who need this technology get to use it. And he told me the story of how they had developed composites for ISRO, and that was cool and all, but he said that he really felt that he did something important when he was able to use the same composites to make tools for leprosy patients. and to see kids who have partial usage of their arms and legs and are really weak, are you able to use composites to lift up a school bag and open books. So that's what fundamentally engineering is all about. It's about solving problems, and there are enough problems that we need to apply ourselves. So we need, and sort of, even my vision for what I want to do is empowering the world to create, making India a superpower by creating and enabling engineers. Again, we started with 3D printing, and we're getting into other things to sort of, go on that vision of empowering creators and makers of the country to do a lot more better. And yeah, so again, I just sort of transition to something that we're doing. The pandemic had got me worried. Generally, we take interns from Manipal every year, but last couple of years it wasn't possible. So I was really getting worried of the kind of engineers we were creating, and I know for a fact that the country and the world in some ways sort of stands on the shoulders of engineers. So I just wanted to sort of quickly talk about this course that we're doing. Hold on, let me just open up the course page. Yeah, so basically, again, I encourage all of you to check out the course page, all the information there, and do see this video that we have made. Click on this and check out the video that is there on the course page. Again, so what how we've built it, we've tried to make this online course as interactive as possible to somehow give a illusion of an internship. Again, that's what we wanted to do, and we sort of take students through a lot of the plethora of skills we ourselves use in Fractal, from starting with the process. Now, I do believe that great engineering build starts with a great engineering process, and that's what we sort of drill into everybody's mind, and then use getting into the tools and technology sort of make those products possible. Check out the full course plan and curriculum, and what this class is all about. Also see the full story of the wind turbine in Antarctica, the oxygen concentrator, and the braille keyboard all over here. And as part of the course, you all will be creating a hands-on build of your own. There will be live Q&As every day. There will be a community platform on which we'll be interacting and sharing your projects and making sure everybody gets the support that they need on your particular project. Me and my team, as well as other experts, will be there on this to sort of support everybody. And yeah, I mean, there's a detailed course plan also that is there on the website. So you can sort of see every single thing, every single day, what we're planning to do, from brainstorming, research, exploration, uh, getting started with the mechanical engineering, different kinds of mechanisms, to electronics, embedded systems, Raspberry Pi, and also very importantly, presentation and storytelling. Because I honestly feel the only reason why, say, somebody would say that the US or UK is better than us is because of uh, just again our ability to document and storytell. And this is something that sort of has helped me greatly in the last few years, since we started. The ability to create good documentation, the ability to tell your story. I will be sharing my own insights and anecdotes about these, and making sure that as engineers you're not only capable of making things but also telling the world about them, and getting people to care about what you've built. Um, so yeah, that is my talk. uh, we can get into question and answers if you have any questions about like
Yeah.
my journey in entrepreneurship, questions about how I dealt with my college life, or questions about the course. So yeah, thank you so much for having me. Thank you so much for listening.
Yeah. So hi guys, it was really nice to have Vijay on our side. Like an amazing journey from being a student at MIT to working at Fractal Works. I would request Dr. Srisha, who's HOD Electronics and Instrumentation Engineering, to talk about how this is going to be an ITR for the instrumentation branch, and to explain it to instrumentation students as well. Thanks a lot.
Yeah, good evening, Radha, and all the participants.
Good evening, sir.
Yeah, good evening.
Good evening, sir.
Good evening to Dr. Prabhakar, faculty in charge of ISA.
Good
Yeah,
evening, sir.
good evening. Good evening. So, good evening to everybody. Very much fascinated with the journey of this Fractal Works. As a student of MIT during the second year, third year itself, they have had this innovative idea and grabbed the opportunity available in the campus, because it is mainly what is required is exploring the opportunities. Many of us keep waiting for the opportunities and we are not able to do any start. But what they have done is they explored the opportunity, whatever is available in the campus. In addition to academics, they have grabbed it, and from that they have grown to this level, which is highly appreciable, and you cannot imagine that in a short span of 8 to 10 years they are owning such a huge company which is having so much of value addition in the industry. And I am very much happy that Vijay is interacting with you, and recently in month of April even other partner of the Fracktal Work, Mr. Asil Rohit, has joined in such a talk with our E&I students. So both of them were very down to earth, humble, and we cannot make out that such a attitude also can lead to such a high positions and high contribution to the society. So all their contributions, starting from 3D printer, anyway, that is very much useful for the industry. But in addition to that, during this pandemic time, if you see what they have done, wind turbine, face shield, oxygen cylinders, oxygen concentrators, so these face masks, so these are all very much need of the hour at that time, because we are having such a shortage, and in such a poor health infrastructure in the country. This, if they are not contributed in this direction, in this magnitude, the nation should have suffered a lot in the first pandemic. And because of those contributions now in the second pandemic also, even if it is not such a huge level, we could manage in a short span of 1.5 months and try to get it controlled. So this contribution of them in the societal needs is really appreciable. It is heart touching. So I congratulate them and appreciate them. In spite of this much achievement, they are so close to institution, interacting with the alma mater, and telling the institution has made them to this position. This is really, really appreciable, because once you go to high position, many people will forget the root cause where they are grown, and they will simply don't remember that. But this is very much heart touching for me, that both Rohit as well as Vijay are repeatedly telling in every meeting, every interaction, that institution has helped them and institution has given them the opportunity. This is a very good, what you can call human touch of theirs, and it shows their ethics and culture. I appreciate that. Coming back to this training part, so as it is designed for 4 weeks, definitely I feel it is fitting to our requirement of industrial training of 1 credit course. We have to do during the entire course period, any time during your summer vacation. So the course outline is very much useful for any engineering graduate to build his career, to contribute to entrepreneurship. So, and also it helps them to present their ideas and how to build that idea and how to nurture that idea. Because of that, I definitely feel it is very apt for the students to take up it as their industrial training. From our side, I fully recognize this, and those students who are taking for this 4 weeks course, I take it as a part of their industrial training, and will be considered as a 1 credit course, because the learning of this is definitely going to help the students to go in line with their what they have achieved. So it is really an eye opener for most of the students, and with this definitely they can build their career. So in that consideration, definitely I from our side, from our department, I encourage the students to take this as a equivalent course for their industrial training, which is 1 credit course, and we fully endorse this and will take it as equivalent to that industrial training course of the undergraduate program. So I once again thank Vijay for providing such an opportunity for our students and enlightening them and motivating them, inspiring them. So thank you, Vijay, for your time and sharing your thoughts with the students and motivating them and inspiring them. Thank you.
Thank you so much, sir. Thank you so much for your kind words.
Thank you. Thank
All
you.
right. Guys, we'll be starting up with the question and answers session. You're free to ask anything to Vijay, and if the question pertains to any of the students who have joined the course or who are planning to join the course, or is it related to Vijay's journey, you're free to ask. Go ahead.
Hello.
Hi. Oh, hey, Siddharth.
Hi, Siddharth here. Hope you're doing good.
Yeah.
I just had a basic question. I mean, I was pretty much interested into robotics since like past 1 or 2 years. I was just trying to get hold of it, as in where do I actually start from? So I looked up on YouTube and started watching a few people. One of them was Michael Reeves. So basically, that guy knows how to do stuff from the very basic to building up the whole machine on his own. So I found out there's a Arduino, something like that, then Raspberry Pi, basic operating system. I don't exactly know what they are.
Right.
So I'm just curious to. I also found that there's an Arduino startup kit. So I was thinking of buying that. How to start on robotics. So could you recommend something like where to actually start from? There's a wide range of things to do.
So I'd say robotics, right? Again, as somebody who was in robotics when or at least used to build robots when I was in college. So really, robotics is a subset or is a kind of field where you have to draw on multiple disciplines of engineering, from mechanical design, electronics, and computer science, and it comes together and converges into making something like a robot. Um, so over time, I realized again my ability to build robots and bring these different fields together could be applied to a lot of different things, and vice versa also, right? Ultimately, you need to have like a basic understanding of these three elements that come together and build robots. Now, I would tell you, yeah, for sure. I mean, these are things that I'll be covering in the course. But apart from that, where I've learned everything that I've learned from is mostly from the internet. There were definitely things from college also that helped out. Um, there are a lot of learning resources online. I myself taken up like so many courses after college, right? From design thinking workshops, from like taking like in depth into Python, in depth into C, in depth into IoT, just to understand what these all of this is all about. And many of these, again including IoT, is all similar, where you have to bring mechanical, electronics and computer science together to solve a problem. So robotics, I'd say, is sort of a subset. What I'm also trying to talk about and teach in the course is sort of the foundations of all of these, and the foundations coming together in a complete mechatronic robotic. Again, you can build a robot as a part of the build in the course, but ultimately, getting started is definitely, again, not as difficult as it used to be in my time. Again, that time, Arduino was just coming out. We didn't even have the Arduino Uno back then. But sort of for me, especially the Arduino, where it brought together two fields which I did not knew met somewhere. It took electronics, it took computer science, and mixed it together, and it blew my mind. And then you get in sensors, you get in actuators, you start interacting with the physical world, you start building mechanical systems, and sort of it's crazy. As a mechatronics engineer myself, sort of I am able to leverage one to another. Say, for example, if you want to make your mechanical design as simple as possible, but you need high accuracy, You can load up on your electronics with high precision sensors, or again on your control algorithms for accuracy, and then make your mechanical design a little simpler, or vice versa, right? You can go high precision in your mechanical design and use simpler code in electronics to sort of run a system. So as an engineer who is able to sort of like play in these different fields, sort of the entire world is sort of complete the sandbox where you can easily navigate between one to another. And I think that is a real advantage of, I mean, robotics is one thing, but if you step back, it's about using these three wide disciplines of engineering interchangeably to solve any kind of problem.
All right, so in the course we'll be taught about all of these things, right?
So do one thing. I mean, if you're interested, you go through the course plan. Okay, on the website, navigate down, you download the course plan that gives you a video by video, of all that we are teaching. So that has
Okay.
Arduino, that has basics of C, that has Raspberry Pi, and again, so the course is also is for beginners, where you can sort of, it's like a buffet menu, right? There's a lot of things that we'll talk about. Um, from basic, intermediate, and advanced. So if you're somebody who's just starting out with various different things, you can pick up say Arduino from it, you can pick up mechanical design from it. But if you're already say an expert in say CAD, like you already know Fusion 360, which also we'll be teaching in the course, you don't have to sort of obviously learn that part, but there are other disciplines that you want to pick up. So this course is one for somebody who's just a beginner, who want interested in all fields of engineering, or somebody who already has expertise in one field. So say you're an expert in electronics and code, but want to pick up skills in mechanical design so that you can build complete systems. So they too can benefit from this. And if you're somebody who is experienced from this, definitely we'll be sharing a lot of. I mean, I myself will be building 4 projects on my own using my own experience, as well as talking about all the projects that we've worked on, from the 3D printers through to the oxygen concentrator and all the various projects that we have worked on, and how sort of these things, we're going to give practical application based knowledge. It's not just theory where you study this thing and then I mean, in my experience, I've never been able to learn like that. It's always been
Right.
practical. So I'm
Even
going to
I
be.
was interested pretty much in climate change and everything. So that I was coming up with new ideas, but didn't know how to put them into a machine. I mean, I
Yeah,
was
and
doing
and
some Fusion
so
360
again, it's
work.
all about practically starting. Again, I didn't know anything about generators and turbines before I started, but by
Right.
doing something, by making something, I have right now I'm good enough where people are calling me for like advice and consulting. So it's really
Yeah.
easy. It, it's crazy how easy things become when you start making it yourself. And that's the reason
Right.
why we were very adamant from the start that this course has to be hands-on, and it that is really the way to do engineering has to be hands on. And that's the kind of experience that we are hoping to even give to the students, where as a part the 1 week, right, 1 week there's no technology involved. 1 week is all about planning, preparing, design thinking, and what we believe is a good design process, a good engineering process leads
All
to a
right.
good engineering build. And before you start off any skills, right, we want to drill it down, because I think it becomes too much of engineering is all about skills that you have, whether you know how to use an Arduino, whether you know how to use a Raspberry Pi, whether you know how to use something else. And I'm telling you, it doesn't matter. An engineer has a proper and has an engineering thought process, and that is most what is important. And through research and learning, you can pick up the skills that you want to know. So for example, if I was building the wind turbine, right, I do not know what skills, what it has a lot of electrical engineering into it, and I'm not an electrical engineer. I didn't understand how do I build a rectifier and all of that. But
Right.
ultimately, putting down high level list of features that I want, breaking it down in small parts, and then it's just a simple Google search, right? Again, the internet is available to you. Understanding, okay, fine, this I need to figure out how to build a full bridge rectifier for this specification, because my wind turbine gives me this much wattage, and I'm able to find resources online and figure out that. So that's why the first week is all about just the process of design thinking and engineering. and subsequently you will start buying the components that you need for your build. Like, it's not that you follow me and make what I'm building. No, you, each and every one of people who are taking the course will be um, thinking about something that they want to solve for themselves, either something for their community, something for their home, something for their mother, helping them cook, uh, enforcing a good habit, preventing procrastination, so many things. Like, it can be anything. So go through the process of figuring out an idea worth solving, a problem worth solving, figuring out how to create the requirements and constraints. How do you funnel those ideas into a final engineering solution, and then how do you apply the tools and technology to solve the solution. So engineering, all the electronics, that doesn't come first. First is the problem, then comes the solution, and then comes the technology behind it. And ultimately, this is the correct way to do engineering. This is what sort of we'll be talking about in the course, and sort of going through the entire process, which we hope at the end will make you not only engineers but problem solvers that are able to apply yourself to real world problems in the world.
All right, thanks a lot. Hello, this is kind of an off-topic question. Not really off-topic, sir, but okay. So I'm also thinking of making a wind turbine generator for my terrace, so that I can power the lights. Like, we use LED lights in our terrace, and they're connected to the main board. I was thinking I'd build a wind turbine generator using hoverboard motors. And
Okay.
yeah, like they're 350-watt motors, so I think that would be good enough for the LED lights for the terrace. But I wanted to ask, what kind of motors did you use for your wind
So
turbine?
that's the thing. So I made my own generator in the turbine. So what happens when you use a motor in reverse to become a generator, right? You lose a lot of efficiency because of you have your stator and rotor, right? You have your metal, your wire bound around a metal pole, which sort of attracts the magnet when it is functioning like a motor. But when you're doing it reverse, right, you don't need to have that metal core. And what that metal core does, nothing but sort of reduce your efficiency. If you see how in commercial scale wind turbines, you check out I think Brit Air, BRITAIR, they were a company that was making wind turbine, large 10 kilowatt wind turbines, and that was the inspiration between my own wind turbine design. So I created a dual axial flux generator itself, which is very efficient design for a generator. And the same form factor, same size, same amount of wind, I can generate up to 2 to 3 times as much more current and voltage, power basically, than just using a generator in reverse bias. So do check out the Portal Point generator. It's open source. It has its own Hackaday page. You can learn more about the generator like that. Why I decided to make my own generator when nothing off the shelf was sort of worth it.
I think I've heard about these generators. These are the coil and the magnets are placed in parallel, right?
Yeah, it's
Yeah.
axial. So
Yeah.
it's like a sandwich. You have a stationary stator, then you have two rotors which with magnets on either side. So the flux dense, because you have magnet on this side and on this side, the flux is very concentrated between the two magnets and going through your stator in the middle. So there's a amplification of the amount of current and the power that you're generating. So that's the reason why I selected a dual axial flux generator, because it's a lot more efficient. Ultimately, I had to carry it to Antarctica, so I wanted something that was portable.
I actually had a question which is like sort of a continuation of the first question. So I'm asking this behalf of on all the people who had asked me this. So how is the sourcing of kits going to be done for the course? Because a lot many people are living abroad also, and they want to enroll for this course. So If you could say something about this.
Sure. So one, you will not need to touch any hardware until the second, third week of the course, right? You wouldn't need to touch any electronic hardware at all. So we're going to go through the design engineering process first. Second thing, it is recommended to have, again, it's not a necessity, but it's recommended to have at least a Raspberry Pi with assorted sensors and actuators and electronics along with you. If you are new to electronics and code, if you've not done it before, we are going to have it on our web store as well, so you can buy it from us. But at the same time, if you don't want to invest in it, you can borrow it from your friends or somewhere, or a lab that has it. But ultimately, by the end of the month, we will have it on our online store, and people who have signed up will be having a getting discount on it. But ultimately, it is an optional thing. Now, if you are somebody who wants to build something a lot more advanced, you need a Raspberry Pi, or you're using an ESP32 or something else, right? Again, since the course is open for all and you might be experienced in electronics to begin with, and you want to use something else, then it's completely up to you. You don't have to buy an Arduino. But yeah, for people who are signing up, you will be getting a email soon. And anyway, once you sign up, there will be a list of components that are recommended to have. It's a long list of components, which is basically just like a suggestions, really, rather than you need to have this kit to succeed. No, again, primarily what we're trying to put into everybody's head is the design engineering process, which is sort of what, honestly, which is what will serve as a guide for you, not only during this course, but hopefully for the rest of your life. And you'll be able to pick up electronics board skills as needed throughout your life. So yeah, again, the Arduino is not something that is necessary, but for somebody who's using it in a project, of in the project that they will be building, obviously it's something that's needed. And for somebody who is using first time with code and microcontrollers, then it is necessary. I would say it is recommended that you need to have, and you'll be able to get it from us very soon.
Okay.
Also, like, okay, so what about shipping outside the country? Like, some people are in UAE, so
Hmm.
with the components, if they are planning to build a project and they want to get a kit from the website itself, so is it available for shipping outside?
So one is, again, somebody did ask me about this. The UAE also has web stores where you can get Arduino, Raspberry Pi, all components and all. So I would not recommend it buying from you. It'll become unnecessarily expensive when it comes down to international shipping, and then you have customs already. So it is best for you to procure locally. That's the reason why for people signing up, I've given the list also. It's not that, again, you have to buy from us, but if you have access to it, if you have a friend that has it, I mean, I know that Manipal Dubai also has like a electronics lab. I'm wondering if you can probably go and use it at their lab. I don't know, but yeah, you have the entire list of components that you might need when it comes down to learning Arduino. You don't have to buy it from us. If you can, if you want to, but ultimately it'll be more expensive to shipping, and international shipping isn't a problem. We ship our printers internationally all the time.
Okay, I guess that answers us. Thank you. Thank you so much.
Uh, what, like, is this, like, there's a common question that is this course a self-paced course, or is it an interactive session, or like, is it fixed for 28 days? What if people are not able to complete it within 28 days?
Yeah, that's a good question. So no, it is not self-paced. But at the same time, if you see the course curriculum, right? So the first week is about, again, we've at the same time we've given enough gap for everybody to be able to do something, right? It's only that you shouldn't overestimate yourself and pick up a project that is incredibly difficult to work on, and that will be sort of difficult to sort of finish by the end of the course. But ultimately, because you will be issued a certificate only if you complete a build of your own. So week one is about identifying a problem worth solving, going through the design engineering process, and figuring out the features and requirements and your constraints of the project that you want to build. And again, that is simple to do. The first week is all about sort of planning, so there's no experience that it needs. Week 2 onwards, we'll be going deep into skills across mechanical engineering, electronics, and code. Now, this sort of serves as a buffet menu where I'll be teaching beginner to advanced level across. Again, simple, almost craft level mechanical building with, say, wood, with ice cream sticks, with PVC pipes, to more advanced level mechanical design with aluminum extrusions, with 3D printing, with CAD design. So depending on your current skill level, you can obviously learn the advanced things, but you make use of what you have access around you. Say for example, if you are from Bangalore or Mumbai or like a tier 1 city, you'll be able to get your hands on aluminum extrusions, but not everybody it has. So we're giving enough options for people to do different things. And week 2 onward is completely like is dependent on the project that you pick up. And ultimately we'll be talking about, I myself will be making multiple projects during the course, which will give you ideas to implement into your own builds, your own projects. Say if I'm using springs in a certain way, I'm making like ratchet mechanisms for achieving a certain thing. You can see whether that applies to you. So it's a buffet menu of various different skills. You pick up what you want. Say if you want to learn Arduino, you want to learn Fusion 360, that is there a part of the course. But it is not, you're not like, there's no quizzes on Fusion 360, or there's no quizzes on Raspberry Pi. Ultimately, you use what you can to build a complete mechatronic robotic kit or a project at the end, where you're utilizing aspects of mechanical engineering, electronics, and computer science to do something at the end. That is the only requirement. So you don't need to sort of um, go get at the high level, because we understand that again, engineers are obviously of different levels, different branches. Somebody might be good at uh, mechanical engineering but are just starting off with electronics engineering. So this course is designed to sort of up your current skill level and give you access to understanding various other domains, right? I start the video by talking about changing your identity. As a mechatronics engineer, I think the biggest advantage that I've gotten is the identity that I have to be able to play with different other lot of other domains. And interestingly enough, a lot of my peers who graduated along with me, who once they get into masters, when they get into jobs, again have to actually learn aspects of other fields. And this is, in my opinion, what is most sought after if you in careers in the future, where again it's not black and white anymore, where you going to get a career where you only will be using mechanical engineering, only will be using something else. Again, even as a mechanical engineer, if you're getting into something like generative design, you have to work with sensors and data collection and data acquisition. There's so many other fields, and it's always like a correlation of fields that come together. So this course is designed to completely change your identity, introduce you to various other domains and fields, and also at the end, I'm going to be teaching you how to keep learning, how to keep picking up. And like the example I gave, right? When we started the oxygen concentrator, we had no idea about how the PSA system works and how to generate oxygen. But ultimately, within that framework of knowing how to apply, gain knowledge as you want, how do you read research papers, how do you ask experts, how do you fill in the gaps, that's what sort of this course is all about. It's not possible to sort of make you like a complete like hero with engineering to be able to compete with Elon Musk in one month, but it's able to get you on that track where you have access to different fields of engineering, not scared at anymore. I think that is something that I think, even as me as an engineer, when I have to pick up a new field, right? It's something that is scary if I have to learn, like embedded systems with Linux or embedded Python or MicroPython. It's scary to begin with, but once you actually start getting in, you dip your toes into that lake, you get to know that it wasn't as difficult as you thought it would. And that is the sort of crux of the course, where we'll be introducing all the different concepts. So things will be familiar to you, and you can start implementing it. Again, the videos in the course is available for you perpetually. You can always revisit it and pick up the skills again. But it forms as a introduction from basic to advanced level, where you can pick up these skills.
Alright. I've got a few more questions. Number one is, by when the starter kits will be made available? Like when a person starts the course and has gone through the course plan and has kind of decided on making something, by when the kits would be available to purchase?
That's what, like, definitely there'll be a lot of enthu cutlets out there who know what they want to make before the class has also started. So one of the
Yes.
reasons why sort of you should, you, I mean, you need to leave who you were at the beginning of the class. Like, leave all your assumptions, trust in the process, go
Right.
through the process, and then come down to what you want to build. If you already have an idea of what you want to make before you get in, then there's something that is going wrong. You are bringing your own biases into, like, hey, this is something that I think is right, and that's why it solves the problem. So let's go through the process of, design engineering together. You might get to the same product. That is completely up to you, but ultimately we're going to do it the right way. And then again, there's enough time. So there's 3 weeks for you to finish your build.
Right.
So there's enough time to make something. I mean, we built an oxygen concentrator from scratch, from start to finish. So building something of your own capability, your own level, should be possible in 3 weeks time. So I don't think that is too much to sort of ask for. So kits will be made available by the end of the month. Ultimately, that kit is only for people who,
Have
are
registered.
building something with Arduino or want to learn Arduino. But ultimately, it's all up to you what you want to build, right? If you want to build something which has IoT capabilities, then you can't use an Arduino. You need to use a ESP8266, or you need to use a Raspberry Pi. If you want to build something that is like a robot, then you need motor drivers and wheels, which is not part of the kit. I mean, if you want a kit that is from which you can make anything, then it's going to be expensive. But ultimately, throughout this process, again, we have to go through the process, because this is exactly what we use, right? I mean, I will not buy things before I have thought about what I'm going to build. Only after the initial design is done for the oxygen concentrator will I start, placing orders for things that I want. It'll start coming in. I'll start building it, and that is a process that you need to use. So you don't have to be prepared with it before, because ultimately, even if you buy the kit before, right, end of week one, you'll need to place orders again with different
Right.
components that you will need for the project that you will be working on. So that's why, again, don't worry about the kit that much. It's not as important as you think it is. It's more about going through the process, and at the end of week one, you will be buying a lot more components specifically for your build.
All right. So another question is, after the completion of this course, can we do, will we be able to code microcontrollers on our own?
Yes, you will be, for sure.
Okay. All right. The other one is, will the course be an interactive class with fixed timings or like a pre-recorded set of videos?
Okay, so this is where the interaction. So, like I earlier told you, we're trying to make it as interactive as possible and give you the experience of an internship while being an online course. So the modes of interaction and learning is, one, you'll have video lessons for every single thing, and that's outlined in the course curriculum on the website. Second is, each course video will have a discussion forum, almost like a Facebook sort of like comment section, where if you have doubts, you do not know what is happening, you can leave feedback, etc., on each course video itself, and interact with other students who are taking the course along with you. A second form of interaction is, we have a community forum where everybody, we're creating a cohort. Again, like from my own experience of, when I'm taking courses, when I'm attending conferences, when we're doing it together, it sort of accelerates learning to a completely different level. And as a part of the course, there's also a lot of professionals taking the course. There's somebody from Aether Energy, there's somebody from Ultraviolet, there's somebody who are professionals who are also taking the course to skill themselves up. So it's not just Manipal students that are there, and all of them will be interacting along with you, and you'll be interacting with them. There might be somebody who's expert in one field, somebody expert in other field, but ultimately it's about cross pollination and learning from each other. And the final way of interacting, we'll have a fixed time Q&A every alternate day, where if you are stuck on something, you have doubts that you were not able to get clear on either the community platform or on the discussion of the video, you can get answered in the live Q&A. Every day we'll have 1 hour live Q&A where we are getting questions from people, from the students, and directly interacting with them about their projects. Say if you want to know how would you power your device, again power management on your project. Obviously the power management in itself is a topic that is not being covered in this. Obviously there are resources online, so we will help you get access to the resources, show you what you can do, suggest what IC, what chip, what you need to use to do battery management or power management for your this thing. So it's designed in a way, it's as interactive as possible, but also we're trying to make you as engineers as self-sufficient as possible, because ultimately everything is available on the internet. We want to make sure that you have the ability to ask the right questions. I think that is most important, knowing what you need and then asking the internet for it. So we are here to help you understand what you need done, right? You pose a problem for me saying that, hey, I have a battery, I do not know how to do this. We can help you saying that this is what you need a battery management solution. Once you have that keyword with you, then sort of you can go gung ho about it, search the kind of problem, and also sort of get it passed by us saying that, hey, this is what I've selected, and then we can say, yes, this is the right choice. So yeah, that's the various ways in which we'll be interacting in this course.
All right. Also, there's another question that since the registrations end on 30th of June, number one, the course would start from 1st of July, right?
The course is starting from 10th of July. We need some time to sort of once we have the final list of people who are joining in, you'll be sent your login details for your. We have a learning management system. You'll be sent login details for your learning management system on your email, and then you can start getting it. So 10th of July is when it actually starts.
Okay, so the course should go on from 10th of July to 10th of August, right?
Yes.
Or 9th of August.
So the course itself, when it comes on interactive, it ends at 10th of August. But ultimately, you can take a couple of weeks more to finish your build. And the final submission will be a video submission where you're talking about, again, since the last week is also about presentation and storytelling. So the final presentation will be a video presentation where you're talking through your journey of building your project, showcasing how it helps somebody, showcasing how it helps you or somebody else. And that is your final submission. For that, you can take almost the entire month of August. So it's just that the live Q&As, everything will be like the course itself, content itself is still the 1 month, but you can take another couple of weeks after that to finish your project and submit your video.
All right. Okay. So we've got another question that is, it's not related to the course, but it's like, how do you decide your software suite for beginning a project? Like, how did you start with the 3D printing area?
So is the question how I started with 3D printing?
Like, how did you get the interest, or how did you come to 3D printing, and how did you discover it? Or what is a software suite basically? The question is, how do you decide your software suite for beginning a project?
Oh, interesting. Okay. That is also something that obviously I cover in the course, right? So
Okay.
that doesn't come first. Software suite, hardware suite, all of that comes much later, right? As an engineer, you are a problem solver, and to solve a problem, you need a problem to begin with. So it starts there, right? What is the problem?
Right.
What are the requirements? What are the constraints that you have? Can be like budget constraints, availability constraints, blah blah blah, whatever. Then you go to solution. What is the solution that you are going to build that meets those requirements and constraints? And then you have your solution suite, whatever you call it, the technology that you apply for that solution. Ultimately, where most people go wrong, and this is something that I've personally seen so many times at hackathons and events, where you come with your own experience saying that I know how to build something with Raspberry Pi, Arduino, blah blah blah, and sort of it's like a hammer, right? Sort of you come with a hammer and then you want to see what you can hit. That is the wrong approach to engineering, right? You want to understand the problem, you want to know what is the right tool that is required for that problem and engineer that tool that solves that problem. So there's this two ways of doing engineering. One is the right way, one is the wrong way. Don't come with a hammer and try to sort of try and break things. To engineer the right solution, to build the right tool for that problem, you need to go through that process. So I'd say again, it doesn't matter like whether I was building uh, 3D printers right in college. Right now my printers are a lot more advanced because I've been able to up my skills in embedded Linux, in software to give a better experience. But ultimately, with what my limited knowledge was in my third year in college, I was still building robots, building 3D printers that I was able to sell to customers. So that's the point I'm trying to make, where it doesn't matter, your skill sets don't matter as long as you use the proper process and which solves the problem at hand. And yeah, again, like don't get too enamored by sort of tool chains and things like that. That all of that comes later, but the process, engineering process, is what comes first.
All right. Also, there's another question from the same person, that is, how worth is it to try to contribute to open source project that you use by getting to know them? Like, how worthy is it to contribute to open source projects, basically?
How I think that's it one is great on your CV, right?
Okay.
It looks really good saying that hey, you as a developer, you're able to give your extra time to this open source project, and this project is doing really well. There are, again, for example, if you how many of you know about the Ingenuity helicopter that's on Mars? I don't know if you can show your hands, but okay, fine. Did you know that a lot of the code on the Ingenuity helicopter was open source and sourced from GitHub? And uh, everybody who wrote code that ended up on the Ingenuity helicopter has a badge on their GitHub account saying that hey, this code is on Ingenuity helicopter. Again, even like again, if you know about SparkFun and Adafruit, which is like open source hardware companies that make like tiny boards and sensors and things like that, those open source hardware products are on the Ingenuity this thing helicopter. So you never know where your code will end up. You never know who will attribute to you. Again, me personally, I've had a amazing experience with the open source hardware community. Both the projects, the Wind Turbine as well as the Braille keyboard, won a Hackaday prize in 2017, 2018. Um, and got me a lot of money as well. And at the same time, got so many people interested from around the world that are contributing back into the project and making it better. Much better engineers than myself have taken my project and made it better. And what better feeling than that? And ultimately, you have this knowledge and is available to the internet. It is going to help somebody who really needs it. Somebody who's been working on creating the wind turbine so that they can use it for remote villages in the Himalayas. Obviously, me sitting in Bangalore, that doing that is not possible, but at least something that I've done is helping somebody. So that way, I think in terms of goodwill you generate, in terms of your credibility as an engineer, definitely helps. In terms of commercial interest, I mean, it might work, might not work. That is a iffy, dicey sort of question. It works really well so far for software, but again, not all of the time. Open source hardware is something that is just picking up. It's something that is brand new and has just come up in the last 5 6 years. So yeah, I mean that is my 2 cents on open source hardware in particular. Software though is going on for a long time.
Okay. Just one quick question, and we are planning to end the session. So the question is, like a few first years are having their results out on 30th of June. So can the course deadline be like the registration deadline be extended a bit, because a few students have to make a few decisions. I don't know what exactly, but there have been a few requests.
Um, okay, I mean that shouldn't be too much of an issue. Uh, we can figure that out. Yeah, fine. I mean, if there are not too many people there about that, we can figure that out. That shouldn't be too much.
Right.
We can probably extend it for 5 days if because June 10th, sorry, July 10th we have to start. We can still get work with a 5 day buffer. So
Right.
if they're fine with a 5 day increase, we can do that. Start the course on sorry, course will start on July 10th. But we can probably keep the registrations open till 5th of July.
Right. Okay. So
Hello, yeah. Hi, sorry to disturb. I had a question. So about the week 4, where it's about our build. What exactly do you mean by our build? And you said that the Arduino kits are not really necessary unless you're doing a build with Arduino kits. So what other projects can we do as our build?
So
And
throughout
also sorry, one more. This one is it all supposed to be coming from our head? Like we can't take ideas from elsewhere, or is it just our innovations?
no, I mean, so I sincerely believe whenever you have a thought, no, not almost there's nothing. It's not possible to have an original thought anymore, which is really sad. Whenever again I'm also sitting and thinking about, hey, this is a good idea. It might become a startup. Then I first thing I do is go online and search if somebody else also had this idea, which inevitably somebody else has. So it's not about it has to be something from your head and nobody else in the world has done it. So it's not about that. It's about a problem that you want to solve. Again, the problem that you face can be unique, right? I mean, you obviously human being and there's like billions of people around. You can also have the same problem as somebody else, but ultimately, it is something that you want to see solved, and you're not able to get it solved by some off the shelf part. So you can take inspiration from projects online, you can take inspiration from projects that I will be making, but ultimately it has to be something that you make. And like I said, it's the process of putting all those bits and pieces together. Say, for example, your project might need a display, it might need a sensor, it might need some sort of actuator. There might be three different projects that you derive the solutions from. You might take the library from one, you might do something else from something else, and put it together in your unique build. So it doesn't have to doesn't it's not like we'll be doing like an audit saying that, hey, this is something that somebody else has already done. No, this is something that you have to be proud of, that you've made for yourself by going through the process, right? And that's what I'm trying to say. It's the process is a lot more important when it comes down to the problem that you want to solve and the solution. Whether it's a product that somebody else has made and you are taken inspiration from that and made it, or something that you've completely made from scratch, it doesn't matter. But ultimately, because you've gone through the entire process, you will be able to tell a story about it unlike anybody else. It's not just something that you've copied online and made for yourself. You know why this problem is like this, why you decided on these features, why you decided to narrow it down like this, why you decided to use this electronics mechanical parts and this kind of code to make it work. And that process of doing things that particular way is how we do it at Fractal, how every engineer does it outside. And that is what we want to teach more than anything else. So it's not about even the build, but that entire process of getting to that build, going through all the steps is what is most important. I hope I answered that question.
Kind of, yeah. All right, thank you.
all right. We'll just wrap this up quickly. Thank you very much, Vijay, for it has been an informative evening and it was indeed fruitful. We thank Dr. Srisha as well to join in, and Prabhakar sir and Shashank sir as well to join in. Um We got to know a lot about your accomplishments in this field and how your team has done commendable work and progress during this pandemic, building oxygen concentrators, face shields, and thereby helping mankind in totality. Uh,
Yeah, you guys,
but this is
my
not
my
it.
goal is to make all of you contribute to mankind in totality as well.
Right, right. Agree, agree. We all will try to fulfill that position as well. So guys, do register for the course. The course details and stuff have been given to you and have been circulated throughout your college groups as well. If you do not find the proper information available, you can contact Arvind or Achyut from ISA for the course details, for where to register, what all, and you can go ahead and ask us stuff in the WhatsApp group as well so that we can communicate it to Vijay and your queries could be clarified. All right. Thanks a lot, guys. It was a nice evening.
So thank you so much. You can be in touch with me directly also if you want, on Instagram, preferably on Facebook, on our Facebook group, for a Facebook account, and also use coupon code mighty for a discount at checkout.
Thank you.
Okay, thank you so much, Vijay sir, for joining